Hey, what's up everybody? It is Mr. Boylan, and it's going to be a short video today. We're going to talk about how we can use the activity series to determine if a given reaction will occur. As always, we're going to break that down as you take a look at some of our criteria for success. Number one, we're going to explain the significance of an activity series. What is it? Why do we use it? Why is it important? Two, we're going to use the activity series to predict whether a given single replacement reaction will occur. And then three, if we determine the reaction will occur, can we predict the products in a single replacement reaction? Okay, first things first, what is an activity series? How are we going to use this thing to help us determine whether or not a chemical reaction will occur? Well, an activity series is just a list of elements that's organized according to the ease with which those elements undergo certain chemical reactions. And it's going to be really useful then to help us predict whether or not a chemical reaction will occur. All right, if you take a look at your notes there, you're provided with a couple of activity series. One of the activity series is for metals, the other is for nonmetals. But again, it's just a list that organizes those elements based on their reactivity. Okay, and just a couple of quick things to think about when it comes to understanding the reactivity or the activity of both metals and nonmetals. When it comes to metals, we generally think of metals as being more active or more reactive the easier it is for them to lose electrons and form their positive ions. Okay, for nonmetals, on the other hand, we want to think about nonmetals as being more active or more reactive when they are gaining electrons to form their negative ions. So when you're provided a reaction in an activity series and you want to know how to use the activity series, the first thing is to determine, are you talking about a metal replacing another metal, or are you talking about a nonmetal replacing another nonmetal? Okay, but regardless of which activity series it is that you are using, it's important to recognize that the most active element will be placed at the top in the series, and that element that's at the top can replace each of the elements that's beneath it in a single replacement reaction. Okay, so as you take a look at your activity series and try to think about what the most active metal would be and what the most active nonmetal would be, I think it's probably easiest to understand this when you're talking about the nonmetal activity series. Fluorine is the most electronegative element. It's going to be the one that most easily gains electrons, and therefore it's going to be the top of the list. Okay, for the metal activity series, you might be thinking to yourself, oh, we're just going to put the most active metal at the top. The one has got the lowest ionization energy is going to go at the top. And in fact, as you look at the list, it doesn't quite work out that way due to some factors that are a little more complex than we need to get into for this video, but just recognize that the most active metal is going to be at the top, and those that do a worse job of losing their electrons are listed beneath it. Okay, but it's not just about the top dog in that list. You can use any of the other elements in that list to sort of predict what's going to happen in a given reaction. Any element further down the list can replace any element that is beneath it, but it cannot replace any element that's above it. So again, these activity series are just organized in such a fashion so that the most active element is at the top, and then the reactivity or the activity decreases as you move down the list. So your activity series, really important lists. You don't have to memorize these lists. You'll be provided with these lists on any given exam. So what you need to focus on is just understanding how to use them, not necessarily memorizing their order. Okay, so as you take a look at your screen, a quick example. We've got two reactants here. One is copper, the other is silver nitrate, aqueous silver nitrate in our flask there. You're given some sort of particulate diagrams or representations of each of those reactants. As you think about, ooh, am I going to use the metal activity series or am I going to use the non-metal activity series? Well, our element that is by itself to start is a metal, and it's going to replace the other metal in that compound. So we're going to use the metal activity series. The first thing we're going to do is predict whether or not this reaction will occur. And so as you take a look at your list, we've got copper and silver. Copper is higher in that list than silver is, which means that it is the more active element, and it will in fact be able to kick silver out of this compound, and this reaction will occur. Okay, so we're going to add the copper to the silver nitrate solution, and we're going to think about, what is happening here at the atomic level. We've already decided, using our activity series, that the copper is more active than the silver, so this reaction should occur. But what's happening at the atomic level? As we take a look here, the copper is essentially pulling the silver out of solution and jumping into solution itself. And again, as you take a look at some of these silver ions, copper is going to sort of pull them out of solution, and copper is going to jump into solution. So essentially here, the copper is replacing the silver that is in solution. Now, as you see this happen, you notice the color of the solution taking on a characteristic blue color that we see of copper solution. So again, as we think about whether or not this is chemical change or a physical change, the color change is a good indicator that it is in fact a chemical reaction taking place. And as you think about what's happening then at the sort of macroscopic level, what you will see in the lab is sort of the copper having gotten coated by your silver here. So the chemical reaction, the single displacement reaction that we observe here, is copper coming in essentially and kicking silver out or pulling silver out of the solution. Okay, and then before we finish this video, I just want you to think about maybe the reverse reaction here. If we added silver, we now have to the copper nitrate solution. Silver is beneath copper on the activity series, and so we would not see this reaction occur. The reality is it's a little more complex than that. We have to talk about equilibrium, but for the purposes of this unit and for this introduction into activity series and single replacement reactions, you're good to go.